Okay, so as I said in class today, I'm going to make two videos. One will be focused on piecewise functions, and the other one will be focused on absolute value graphs. Okay, so we're going to use this piecewise function often in this video. Okay, so here's the piecewise function. F of x equals, and again, piecewise means there's two or more equations, is going to equal 3 if x is less than or equal to -1. Sorry, I'll make that -1. And it's going to be equal to 2x minus 1 if x is greater than -1. Okay, so again, remember these are called the domains, right? These two things right here are called the domains. These guys, okay? And when you're evaluating, you need to figure out which domain your x falls in before you can know which equation to plug it into. All right. So if I give you two examples, f of 0. So first of all, you ask yourself, where is 0? Is 0 less than or equal to -1, or is 0 greater than -1? And you realize that 0 is greater than -1. So we'll put that down here. 0 is greater than -1. So you're going to put it in the second equation. 2 times 0 minus 1. And if you simplify this, 2 times 0 is 0, and 0 minus 1 is -1. So f of 0 equals -1. Okay, again, 2 times 0 just goes away. Now what if I give you f of -3? Again, you ask yourself, where is -3? Is it less than or equal to -1, or is it greater than -1? And you say that -3 is less than or equal to -1. So you're going to plug it into the top equation. Well, the top equation has no x to plug in, so you're done. And there you go. Okay, so a piecewise function, understand which domain it falls into and plug it in. Okay. All right, so we're going to take that same function, and I'll write it again. So I had f of x equals, we said it was 3 if x is less than or equal to -1, and 2x minus 1 if x is greater, not equal to, is greater than -1. And now we want to graph this, okay? So now I want to graph. That last problem you were evaluating, now we're going to graph. So remember, graphing is different. Here, we need our starting and stopping points. Even if the point doesn't exist, meaning it's going to be an open circle, we still need that starting point. So what we do is we take the domain breaker. This domain breaker is -1, and we plug it in here, and we plug it in here. Notice that this, right here, this equal to, is going to cause the top point to be a closed circle, and because the bottom one does not have an equal to, it's going to be an open circle. So we will evaluate both. This is the top. F of -1 equals 3. And that's done. This is the point -1, 3. And again, because it's equal, this will be a closed circle. And less than means you're going to go to the left. So remember, they're parts, so you either go to the left or right. So if we do the other one, I'll do it a different color so you can see f of -1. We'll plug it in the bottom here. We have 2 times -1 minus 1. That's -2 minus 1, which is -3. So the point we get is -1, -3. And because it's not equal to, this is an open circle, and greater than means we go to the right. Just look at which way the arrow is pointing. So if I look to graph this, all right, I'll do my best to draw a good graph. I got to learn how to put graph paper in this thing. Okay, we'll go 5 in every direction just to start. And again, you'll be given, paper on the test, so don't worry about making it perfect. Okay. So if I start with the yellow graph, the top equation. Remember, when there's no x, when it's just a number, it's going to be a horizontal line, all right? Horizontal line. So we go to this point, -1, 3, -1, 3, and we put a closed dot. And this is just going to be a horizontal line to the left. There we go. Horizontal to the left. Now, we go to the bottom one, a more normal example, okay? Put the point, -1, -3. Open circle. Okay? And now we need to find a second point on that line, so we must count this slope. The slope is 2 over 1. That means up 2 and to the right 1, and we put a point. And since we are going to the right, we can go through those 2 points. And here's our piecewise function. What I would like you to do on the graph is just label your starting points, -1, 3, and -1, -3. And that's all. And there's your piecewise function. 2 pieces of the graph. Does not violate the vertical line test because you have an open and closed circle on top of each other, and everything else doesn't overlap. Okay. All right, and then one more question I have for you guys. This is going to be a question on overtime pay. We did an example like it in class, but we'll do one more. So let's say Larry makes $10 an hour. Okay. If he works overtime, he earns time and a half. Okay? And I want to write a piecewise function. Write a piecewise function. Okay. So, again, we're going to have 2 pieces, right? Okay, f of x equals, we'll have 2 pieces. The first piece is just his normal wage. Now remember, overtime is after 40 hours. So for the first 40 hours, he's going to earn $10 an hour. Let x be the number of hours. So the first spot is just going to be 10x, $10 per hour, and that's between 0 and up to 40 hours, a normal work week, 40 hours. So then this whole time and a half thing, well, that means he's going to earn $10 plus half of that, $15 for those extra hours. However, it's only for the hours after 40. So we must, to figure out this equation down here, we must first take the $10 he makes times his first 40 hours, and we're going to add that to $15. Again, this is the time and a half. Okay? I'm not going to put an arrow there. That's the time and a half. If you want to do this. That's the time and a half he makes. But then we only multiply it by the amount of hours he works over 40. So you take the amount of hours he works and subtract the first 40 from them. Okay? So we'll have 400 plus 15x minus, and I believe that is 200. Let me check real fast. 15 times 40. That's right, 600. Yeah, minus 600. And then we simplify this. 400 and minus 600 give you minus 200. The 15x stays the same. And here is the equation that goes in there. 15x minus 200. And that is when x is greater than 40. And here's our piecewise function to signify his regular work week and then if he works any overtime. Okay, so stay tuned for video 2 over absolute value functions.